I know that all these problems are the same, and that's why doing lots of them is helpful, because it's basically like practice.
But basically, like, I keep getting them wrong. So
Oh.
you're wrong. Yeah. Why am I
Okay.
wrong?
Ella, could you read 15? Is it 15 that we're doing?
Yeah. I'll
Okay, we'll do 15, then 16. Ella, go ahead.
At what height above the Earth would a 400-kilogram weather satellite have to orbit in order to experience a gravitational force half as strong as the one on the surface of the Earth? Half as strong as that on the surface of the Earth.
At what height would a satellite, 400 kilograms, experience half of its weight? All right, now, Serena's having a moment of clarity, and I think what she's realizing is that actually you don't need to do any math here. You just need to remember that gravity is an inverse square law, okay? So I'm gonna do this the really simple way, because I feel like we've spent enough time plugging and chugging with huge numbers, okay? Here's the deal. If you have a good understanding of what the inverse square law is saying, this argument will be pretty satisfying to you. Here's what this argument's saying. At the center of the Earth, there's some gravity and stuff or whatever, but at the surface of the Earth, we'll call this radius, you've got a value of like whatever g is at the surface of the Earth, which then becomes a 1 over r squared law as you go further and further up into space. So for instance, if you are at twice the Earth's radius, because gravity is an inverse square law, you will be at 1/4 surface gravity, okay? And let me say that again. If you are at twice the Earth's radius, you will be at 1/4 the surface gravity. If you're at 3 times the Earth radius, you will be at 1/9 the surface gravity. So really now the question is, where do you have to be in order to be at 1/2 the surface gravity? Here. Now, it shouldn't be too difficult algebraically to convince yourself that that is the square root of 2 times the Earth's radius. Because when that gets squared, it comes out as a 1/2. Okay? All right. Let's do something maybe that you did not expect. If the idea is that you want to be at square root of 2 times the Earth's radius, then how far above the surface would you need to be? Well, I'm going to subtract off the Earth's radius. Okay? Now, in order to understand the answer in the back, we're just going to factor out this. It's r sub e times the square root of 2 minus 1, which, for those of you that know that the square root of 2 is 1.41, this is going to be approximately 0.4 Earth radii. So if you know the Earth's radius, roughly cut it in half. That's about how far above the Earth's surface you'll need to be. Okay? I know that's probably not the most satisfying problem, but it's pretty fancy. I think we would all agree. Yes? Okay, can we move on to 16? Bailey has a hankering for number 16. Is that okay with you guys? Do you want to work on it first?
Yes.
Okay. Work on 16 for a few.